Okay, we're going to be going over this test. Remember, for the corrections, they are back there. I've emailed them out a couple of times. They're in our room. If you go to Documents, they're also in the room where I send messages and I share different things on there. You guys ask questions. Our, what's it called, like chat room? I forget what Google calls it. Anyway, it's several different places. All right. If you're not sure if you have it, please take some copies before you head home. You can do 2 on the front, 2 on the back. So one of those pages you can redo 4 different problems. Okay. Now remember, for the corrections, you have to redo the problem. Just do it correctly this time. And then part 2 is explain to me what you did wrong the first time. Why do we have our calculators? We're not even doing anything. So second thing is just tell me what you did wrong. And the third thing is, how do you know you are correct this time? Right? And with these, there's different ways to show that your answer is correct. You know, and ask your parents to help you with that. And you can get help on any part of these.
Well, you can ask
okay?
help.
Absolutely. I want you to ask for help.
Can we ask you?
If I'm near you, yes. At the time. All right, so if we take a look at these. All right. On number 1, the table shows the metal count. These are pretty straightforward. For the most part, we did pretty good. Remember, my hint to you was that you were estimating on these. So with United States gold medals, so United States gold medals to Russia gold medals, 46 to 24. That simplified somewhere around 2 to 1. Okay? So that's what I was looking for. That one was worth 2 points. Canada had about blank as many total medals, so they had about half as many. Okay, they had about half as many. Some of you flipped that around and said 2 times as many, but Canada had half as many total medals. So look here. 18 is about half of 35. About what percentage of Australia's total medals were gold? So if you look at Australia, 7 were gold, and so it would be 7 to 35. And you just have to figure out what percent that is. That's the same as 1 over 5, and you should be able to recognize that as 20%. Okay, that's what I was looking for there. And again, remember, like for this one, if you wrote 21% and didn't have any work, I marked that as 100% wrong. There's nothing to support you didn't look at your neighbor's answer or anything like that. So just really careful. If you're doing stuff in your head, you better make sure that you are correct and you're not writing where those numbers are coming from. You better make sure you're correct. Moving on to the next page. There are 64 pretzels in a 16-ounce bag, so they all come from that proportion. So number 1, you had to set up a proportion. So 64 pretzels in a 16-ounce bag, that's 1 ratio. That's equal to how many pretzels in a 5-ounce bag? So that was a point right there, coming up with that proportion. And then the rest of it was solving. That's where you would cross multiply. And when you cross multiply, you would have 64 times 5 is equal to 16 times x. And then solve for x, and you have 20 pretzels. And make sure you label these. Some of you are just like, hey, that's my answer. That's not what I was looking for. I want to know how many pretzels. So your final answer would be 20 pretzels. That would be your final answer, not x equals 20. Okay, or 20. What's the number of chocolate covered pretzels per ounce? Well, if it's 64 in 16 ounces, we find the unit rate. We can simplify that down, and that simplifies all the way down to 4 pretzels per 1 ounce. So that would be your unit rate. 4 pretzels in 1 ounce. Yes, sir.
I did 4 P every O and I got it wrong.
I wasn't sure what P and O were.
Up here I have P equals pretzel and O equals ounce.
Cool. So give that back to me after we're done, and I'll give you that point back, okay? Or those points. And then how many ounces does each pretzel weigh? So if 4 pretzels weigh 1 ounce, so if 4 pretzels weigh 1 ounce, then each pretzel is going to weigh 1/4 of an ounce. So each pretzel weighs 1/4 of an ounce. Okay, questions on any of those? All right, next page. Number 3, all of these go together. The first thing is we had to fill out that table. Okay, so the local farm market sells 5 peppers at $2.25. So if it's $2.25 for 5 peppers, right? You could find the unit rate for 1 pepper, and you end up finding that is 45 cents. There are many ways to get that. You didn't have to do it the way that I did it there, but there are many ways to get 1 pepper is 45 cents if 5 are $2.25. Okay? So if 1 is 45, you keep adding 45 cents. Like for 4 peppers, you should have $1.80. Add 45, you get $2.25. Add 45 to $2.25, you get $4.50. And you get going, and you're with 100, it should be $45. So how many could you buy for $20? Well, you could set up a proportion, right? If I can buy 5 peppers for $2.25, I want to know how many peppers could I buy for $20. So then you could cross multiply, so it would be 2.25x is equal to 5 times 20, and then divide by the 2.25, which would give us that x. And we should have gotten, it's like 44 point something, if I remember correctly. So it should be about 44 peppers. No, because you have 44 point something. I just don't like you. Did I mark yours wrong?
Well, I said 45, but then you wrote, is that 45?
Oh, yeah, because I couldn't read it. So again, come see me and we'll give you those points back. And, yeah, it looked like, but I didn't take anything off for yours, right, Elijah? Okay. All right, on C, describe what the graph of this data would look like and name a point on the graph. So when you're describing it, you notice as the cost increases, so does the number of peppers. As the number of peppers increase, so does the cost. So the data would be increasing. So the graph would be increasing. Okay? Meaning, you didn't have to draw it. If you said somehow that it's increasing, both the number of peppers and the costs are both increasing. Or you could say the graph is going up. You could say that too. And then name a point. You can name any of these points. So one of the points is 4 and 1.80, or 145, or 1 and 0.45, or 5 and 2.25. Okay, those are all the points. And remember, the peppers comes first in the point. It's going to be 5 to 0.25 because that independent variable goes first. Right? And the cost depends on how many peppers you purchase. So the peppers is your independent. It's your x. And D, write an equation that relates the number of peppers in and the cost. So you'd have the cost is equal to the unit rate times the number of peppers. That's what I was looking for in D. And then E, what's the constant proportionality? 0.45. Okay, that's your constant proportionality. How do I know? Because it's the unit rate. And the constant proportionality is a number. It's not a variable. It's a number. How are these things related? All right. Next page. It says many U.S. employees received a 3% raise. Suppose an employee made $47,000 in 1 year. How much would she make? He or she make the next year with a 3% raise. Showed two different ways. We struggled with this more than what I thought we would. Right. The first way, and probably how most of you did this, is you took the $47,000 times 3%, which is 0.03. Some of you multiplied by 0.3 or even 3 and figured out a 3% raise. This person would be making millions, right? Not millions, but actually yes, because it would be a 300% raise. So close to it. Like I want a 300% raise. That'd be great. But it's not. It's a 3% raise. So then you would take that, which ended up being, what was it, 1,410. So that number is how much more she makes. So then you need to add it to how much she made previously. That's the 47,000. And you get 48,410. Can you close that door? All right, that's the first way. Yes.
So, if I'm doing test corrections, I already knew how to do that. I just didn't add her what she was getting before. So, do I just do the problem? Do I have to explain anything?
Yeah, you just have to explain, yeah. So you just came up with this right here.
Yeah.
So you were 90% there. And in the second way, some of you got really creative. Some of you found 1% and then added that 3 times to it, and that's great. Here's my motto in life is keep it simple, right? So here's the simplest way to think about this. Okay, so she or he, I'm sorry, could be a male too. They made 47,000. Does it say she? No. Oh, what she it is. That's why I keep using that. All right, so made $47,000. The next year, she made 3% more. Here's the easy way to think about this. She's making 103% of what she made. Means she's making 100%, means that's the 47,000, plus an additional 3%, right? So she's making 103% of what she was previously. And the decimal equivalent to 103% is 1.03. So if you take 47,000 times 1.03, you will get 48,410. All right, it skips that whole find 3% and then add it to the original amount. If you just think of it, how much more does she have? She has 3% more. But she still also has that 100% from before. So that's why we multiply it by 103%. All right. So I think out of all of them, except for the last two, most people struggled on this one. Right here. Getting that second way to do it. Some of you were very creative in looking at the 1%. That's cool. All right, number 5. She wants to paint her daughter's room. The question is, which plan will give her paint that's least red? There's different ways to go about this, but one way that I did, if you look at the plan A, that's 5 parts to 2 parts, that is 7 total. Like if you're thinking gallons, that's fine, or cups, it doesn't matter. That's why we use the generic term parts. Okay? So that's 7 total parts of paint. That means 2 of them are red. So this is 2 to 7. Whatever, you can change that to a percent. I did actually change it to a percent. That's 29% red. On B, that was 4 to 1. And that is 5 total parts. Right? And if you look at the percentage of red, that is 1 red out of 5 total. So it's 1/5 red, and that is 20%. Okay, so that was my thinking when I went through there. Lots of you did something very similar. Some of you looked at it differently, and that's fine. Okay, but if you feel that I marked it wrong, and it's pretty obvious because the answer is B, right, which will be the least red. But if I didn't, this one was worth 3 points. Just to give you an idea. If I took a point off and you're like, hey, you shouldn't have taken a point off. Okay? And the last page. And we're only going to cover 6 here because 7 and 8 ended up being extra credits. So I didn't take anything off. So your total is out of 19, I believe. Instead of the original, no, it's out of 29 instead of 33. Number 6, we should have been able to get this one, and most people did. I'm okay. The train ride at the zoo covers a distance of 2.5 miles in 1/3 of an hour. So if it covers 2.5 miles in 1/3 of an hour, that's our ratio. Okay? And we want to know how many miles per hour does this train go. So we want this as a unit rate. Here's where understanding fractions comes in, right? Because I'll do this over here in purple. You're going to end up taking 2.5 divided by 1/3. That's what we're doing here. I'm going to bring this 1/3 up and multiply it by the reciprocal. So that would be 2.5 times 3/1. I'm going to change the 2.5 to an improper fraction. So that would be 5/2 times 3/1. Okay? And then when I multiply, that's 15/2. Or 7.5. So over here, that gives me 7. That gives me, this simplifies to 7.5 miles per 1 hour, which is what I wanted. 7.5 miles per hour. How far can it travel in 3 hours? Well, this is pretty straightforward, right? You can set up a proportion if you wanted to. If they can go this far in 1 hour, how many miles can they go in 3 hours? But you're still going to end up taking 7.5 times 3, and that equals your X value there. And so you should have 22.5 miles. And each one of those is worth 2. Yes, sir.
So, I have that, but I didn't circle it, so it's hard to know what the answer is. So then it said answer question.
Okay. So that's it for this test. That's all that I wanted to cover. This was out of a total of, 29. Remember, for test corrections, redo the problem. We just did that part. 1/3 of your test corrections is already done. Then you have to figure out what you did wrong and write about it, and then show how you know this is correct. Right? Ask your parents, get creative. How do you know this is right this time? Okay? You can look at graphs, you can look at tables, whatever you want to do to show that. Yes. Hold on. Did this not record? Oh, no, let's see, make sure. I don't think it recorded. No, it didn't record.
You're going to have some very happy students.
Well, you guys will just have to help them on those test corrections, won't you? All right. So for this class today, if there are no questions on your ACE homework, let's look at 1.4. Yes.
On 26.
Okay. Come on.
Check your task manager.
Nothing. Okay, so is that the only one we had questions on?
I had a question on 7 and
7, 9, and 26. Maybe it did save it. It did save it. Whew.
Video basically recorded. Exact same question.
No, a recording is not having you finish it. Don't just put it in. I have to finish your round. Basically, tell you what it is.
All right, so that's not working. So anyway, they just won't get these. I'll try to figure it out. On number 26, let's look at that one first. Of course it is.
Wait, are we going to have the homework even though we don't have questions of the homework?
People apparently do have questions over the homework, so yes, we are. 26, does the graph represent a linear relationship? The answer is no, because remember, linear means straight line. Is this a straight line? No. Okay, so if you're looking at a graph, this is one of our big questions. How do you determine if it's a linear relationship? A graph is super duper easy. Is it a straight line? So this is no. And on B, could the graph represent a walking pattern? Yeah, it could. Right? Like in this case, they're walking about one meter per second, because after 2 seconds, they're at 2 meters, 3 meters, 4 meters, and then at 5 seconds, what happens? They stop. Right? Because time continues, but they're still at 5 meters, still at 5 meters. Now, at 8 seconds, they start walking again. This time it looks like it's a little faster. No, it's the same. It's the same. It's still about 1 meter. And then at 10 seconds, then they walk faster. But here they stop. Then they continue walking. Then they walk a little bit faster. So the steeper the line, the faster they're going. It's like 25 miles per hour, 65 miles per hour. Right? You're going to go faster. You're going to go further in less amount of time. So it's going to be a steeper line. Yes, sir.
So it could always be a walking pattern unless you have like two dots above each other, because you can't go
Right.
like in 0 seconds.
Right. Yeah. Okay, let's look at, what was it? 7 and 9? All right, let's look at 7 and 9. The students in Miss Chang's class decided to order water bottles at advertising walkathon. Hyun obtains 2 quotes for the cost of the water bottles for each company. Write the equation. All right, so for the first one, okay, the cost is going to be $4 per bottle. It's going to be $4 per bottle. That's it. Okay, that's the equation for the first one. For the second one, it's a little different because you have an initial setup fee. So you pay that setup fee whether you purchase 1 bottle or 1,000 bottles. And this is usually, back when I had my math club years ago, I'd buy lots of t-shirts. Like we would have several sets of shirts that I'd get screen printed every year. And I'd have to purchase, do this setup because they have to set everything up, get the pattern ready, and then print the shirts, right? So whether I ordered 100 of them or 10 of them, I was still going to pay that amount. So it's super expensive if I only got a couple of shirts, but it's the same idea. So the cost is going to be $3 per bottle plus that $25 setup fee. Okay, and that $25 setup fee is only a one-time fee. Then you're graphing them, and you would just do, I'm not going to go over that, but in order to graph them, it might be easiest to do a table. So since B is your independent, I would put that on top. Cost is your dependent. So you would do, okay, if I bought 0 bottles, that would cost $0. If I bought 1, that would cost 4. If I bought 2, that would cost 8. If I bought 3, that would cost you 12. 4, and 16. And then on this second one, bottles, number of bottles, and cost, 0, you would still have that $25 setup fee. So if you say, okay, I'm going to do this, and you back out, well, they've already set it up. You have to pay that. But if you bought 1, that's going to be 25, 26, 27, 28. If you bought 2, that would be 31. If you bought 3, that would be 34. And if you bought 4, that would be 38. Sorry, 37. All right, then you would use that table to graph them. And these are just your coordinates. 0, 0, 1, 4, 2, 8. These are just your X and Y coordinates, okay, on your graph. And then for which company do you think you should buy the water bottles? What factors influence? Well, listen, sooner or later these graphs are going to cross. And I think it's after like 100 bottles or something. Yeah, it's after 100. Because 100 times 4 is 100. 100 times 3 is 75. 75 plus 25 is 100. What am I thinking? 25. 25, not 100. The cost is 100. Because 25 times 4 gives you 100. So it's after 25. At 25, they're going to be the same. But after 25, this one will be cheaper. Okay, so if you're ordering more than 25, you want to go with this vendor. If you're ordering less than 25, you want to go with that one. Okay. And then for what number, I already said that, it's going to be 25 bottles. Right, so what I would recommend doing is keep going, so you would continue these tables, and once you get to 25, you would see the cost here is 100, and the cost here is 100. Okay. And then let's take a look at 7. That equation represents the cost for end caps to the advertising and walkathon. Which of the following ordered pairs? So on this one, what you're doing is you're plugging each of these in. So remember, that's your independent. So if we're looking at the first one, the 0 would be your N. So this is N. And the 5 would be your C. So you're going to plug in 5 equals 5 times N, which is 0. So 5 equals 0. Is that true?
Nope. No.
Nope. Then here, this is your C and that's your N. So it would be 15 equals 5 times 3. Are those the same?
Yes.
Yes. Because 5 times 3 is 15. And then on C, you would have 60 equals 5 times 15. Is that the same?
No.
What's 5 times 15? Right. So no, they're not the same. And then the last one, you would have 1 equals 5 times 5. Are those the same?
Yes.
No.
Times 5 is 25.
Wait. Yeah. 1 equals 5 times 5, so that's not the same. 1 equals 5 times 5. So only, which one was it? Only B? It's the only one that worked. All right. Let's look at 1.4. I hope that I can get this to record. This is stupid. Makes me so mad. get why this is not working. All right, so 1.4 is self-explanatory. This is getting me really upset here, if you couldn't tell. It's really self-explanatory. It's basically taking, hey, we have this money. Now, what sorts of things can we do with it? How quickly are we spending it? When will we run out of money? Right? So it's just kind of taking that idea of I have these pledges. Now I have this money from these pledges. Like in this case, now we have on day 0, we have $144. All right, and then these questions just kind of ask different roundabout ways of what happens if you spend this much per day, what happens if you spend that much per day. Now is it showing up there? Okay. So here it says, Mrs. Chang's class decides to use their money from the walkathon to provide books for the children's ward. This is important. The class puts the money in the school safe, and withdraws a fixed amount each week. Look at that chart at the right. You can figure out exactly how much they're taking out each week. Everybody look at that and determine how much they're taking out each week. I heard a couple people say they are removing, which is a negative value, removing $12 each week. Okay? What do we think the graph is going to look like if we plotted these points? 0, 144. 1, 132. 2, 120, and so forth. What do we think the graph would look like if we plotted those? Right. It would go down because it starts at 144 at 0, starts there. Then at 1 it goes down, 2 it goes down. So eventually it's going to run into the x-axis. What happens when you run into the x-axis? Right, you have $0. All right, so that question is going to come into play. Go ahead and use, there's about 10 minutes left. See if you can get through A. Now, I went through these this morning. These are no new questions. All right, but see if you can get through A in the 10 minutes remaining.
This mammoth class also raised money from the law.
A little tired.
How much money is it? Don't worry about it. Suppose the students continue drawing the same amount of money each week. Skip the graph. I know.
We're just doing a sketch. I thought we had to do like real numbers.
Yeah, you are, Andrew. You're supposed to create a graph. I was gonna say something.
Like that, right?
And
And then write an equation and calculate the relationship. Explain what information each number and theory represents. That's what
no, it's like blank times blank equals blank. Or we speak on times what equals money or something like that. It is actually pretty funny. It's funny.
So like 1 week is one week.
W divided by money equals next week.
So 1W equals -12 $. Boom, this is out it.